Today we discuss about routing and services in ASP.NET Core. HTTP or Hypertext Transfer Protocol is the format used to structure the requests and the responses for an efficient communication between the client and the server. Basically, the message sent by the client to the server is called HTTP request. As we know, MVC platform contains three components: model, view, and controller, each with its own role. To communicate with each other, HTTP requests must be sent to the right controller. In ASP.NET Core MVC, this process of sending requests to a specific controller is called routing. Okay, so basically routing represents the process of directing HTTP requests to a controller. ASP.NET Core MVC directs the request from the views to the controllers in the following way. We have middleware components that determine whether an HTTP request must be directed to a controller for processing or not. These middleware components are executed on each request. Okay, so every time we send a request from the views to a controller, the middleware components are executed. The middleware makes the decision based on the URL and certain configurations. Okay, so based on the format of URL, the middleware components decides to which controller the request will be directed. The routing information is defined in program class in the moment MVC middleware is added. This approach of defining the routes is called convention-based routing. If we go to the program class, we will see a call like this: map controller route, which receives two parameters. One called name that allows us to set the name for the route, and another one called pattern, which specifies the pattern based on which the request will be directed to a controller. Okay, the name is not that important. Okay, we can specify any name we want, but the pattern specifies how the HTTP request will be directed. So now let's take a look to this example. Controller equals home / action equals index / ID. Basically, we have three components, okay, for the URL. The first part represents the name of the controller to which the request will be directed. The second part represents the action to which the request will be directed. And the last part is optional and represents an ID. We can send an ID to the action. Remember that the controller is basically a C# class, while the action is a public method of the controller. So basically it's a method in a class. Also, we have that equals home and equals index. Okay, those are default values. In case we do not specify a value for the controller, by default the request will be directed to home controller. Also, in case we do not specify a name for the action, the request will be directed to the index action, yeah, from the home controller. Map controller route method is used to configure the routes of the application. Okay, and we saw here how we can define a default route. The objective of routing is to describe the rules that ASP.NET Core MVC will apply to process an HTTP request and find the controller that can handle that request. Okay, so we can specify how, based on the format of the URL, the request will be directed to a specific controller. A route can be defined that directs requests to different controllers. For instance, in this example, based on the name we specify, the request will be directed to a specific controller. Using web application object, a new route can be defined with a name and a pattern which defines how to do the routing. The pattern is basically a string that defines how ASP.NET Core MVC will interpret the URL. For example, the following requests will that we see here on the slide will direct the request to the index action of the home controller. Yeah. So let's take a look to these three URLs. Okay. The first one sends the request where? To the index action from the home controller. Okay. The second one. The second one, yeah, to the home controller, but to which action? No, as we said before, we have default values. Which is the default value for the action in this case? Still index, yeah, exactly. One second. And in the last case, to which action from which controller is directed the request? We have localhost. Exactly. It's again, yeah. We do not specify any controller and any action, so we use the default values. Yeah. So the default controller is home and the default action is index. The default pattern specifies default values for the controller and action name in case they are not mentioned in the URL. In case a request reaches the home page of the application, the default controller name will be home. So when the browser accesses the address my site of course it's a placeholder for the name of our website, or my site/home, it receives back the result from the index method in home controller. The question mark at the end of the ID means that the parameter is optional. ID is not required and can be a number, a string, or a GUID. What is a GUID? It's actually the short name for global unique identifier. It's basically an ID that uniquely identifies a parameter. Now, on GitHub you can find a sample solution. Yeah, you can find this solution in folder, in this folder, Lab 6 ASP.NET Core Services app. I have already opened this one in Visual Studio. If we go to the program class, you'll notice on line, starting with line 27, that we have this call that we have discussed. Map controller route, which defines a default route, and basically based on this pattern, it directs the HTTP requests to different controllers. Let's go to home controller. Here we have several actions like index, privacy, error. Let's put a breakpoint on index action, yeah, from this class, and run the application. Okay, so when we run the application, okay, we are directed to the default controller and the default action. In our case, it's the action index from home controller, yeah? The breakpoint was hit. And yeah, we need, this is home page. Yeah? Now, if we want to access privacy action, how do we do? From the home controller, what should be the format of the URL? What should we write to access this privacy action. Exactly. So we have to write first the name of the controller, yeah, and then the name of the action. In our case, is privacy. And yeah, now the breakpoint was hit. So it's first the name of the controller and then the name of the action that we want to access. Okay, so convention-based routing was a way to define routes. The second way to define routes is using attributes. Attribute routing uses a set of attributes to map actions directly to patterns. Okay, in order to use attribute routing, we have to call the method map controllers inside the program class. This method allows routing through attributes and can be used together with other methods like map controller route or map area controller route. So let's do the same. Okay, let's comment. Let's go to program class. Comment this map controller route call and uncomment map controllers. Now, basically, we can use attributes to define routes. Here we have a sample controller. It's called test, yeah, and we have 3 actions: home, about, and contact. Each action is decorated with some attributes. Okay, basically each action applies attributes of type route. This attribute of type route allows us to define a route for accessing a particular action. For instance, to access about action, we have to access the route test/about, or to access contact action, we have to access the route test/contact. Note that for home action, we have 3 attributes of type route. Okay? Basically, we can use any of these 3 routes to access home action. If we go on the home page, or homepage/test, or homepage/test/home, the request will be directed to the action home from test controller. Let's go in the solution now, and I will uncomment these lines. And let's put now a breakpoint on this action about. And let's run the application again. If we want to access this action about, how should we do it? What should be the format of the URL? So, what should be the format of the URL? No. So now we are using these attributes that allows us to specify the format of the URL. In order to access this action, the route should be /test/about. Okay, this is the route that it is specified on this action. So now when we access that route, the breakpoint was hit. Yeah. Okay, can anyone say what happens if we try now to access /home/index? What do you think it will happen if we try to access home/index? No? We will get an error because now we don't have any routes defined for that action. Okay, if we go to index from home controller, now we don't have any route applied to this one. Remember that we have commented this default route, so basically now we are using just attributes. As we don't have any attribute on this action, we cannot access it. Okay, so let's try to access to this route home/index, and we get this message: this localhost page cannot be found, as we commented the default route. Okay, I'll just revert the changes so that we can use the default route. It is more easy to use it the app like this. So in this example, we saw the difference between attribute routing and conventional routing. Uh, Attribute routing requires developers to specify the route for each action. Okay, so it's a bit more it's a bit more complex because we have to go to every action and specify the attribute with the specific route. On the other hand, conventional routing routes the request more succinctly via the default route. Okay, so we just define the default route and then we type the name of the controller followed by the name of the action. Okay, and that's it. However, attribute routing allows greater control over the patterns that apply to each action. Okay, so the advantage of using attributes is that we can get greater control over what the format of the URL should be. We are not constrained to use the name of the controller followed by the name of the action. We can use whatever name we want for the whatever format we want for the route. Okay, now let's discuss about methods or verbs in methods or HTTP verbs. When a client sends a request to the server, the HTTP method is included in the request. Okay, so every time we send a request from the client to the server, some information about the request is included in it. This information contains also the HTTP method, which depicts what action the client wants the server to execute on the resource. Basically, using this HTTP method, the client tells the server what to do with the resource. There are 4 common HTTP methods. The first one is get, used to retrieve data from the server. Note that the get requests should only return data and have no effect on the data. Okay. Then we have post, used to send data to the server for processing. For instance, when we want to create a new product, we send some data about the product that we want to create. Or when we want to upload a file to the server. Basically, we are creating new resources. So we are using this post method to tell the server that we want to create new resources on the server. Next, we have put methods that are used to update data about a resource on the server. So basically, they are telling the server we want to update information about an existing resource. And delete, which of course it's used to delete a resource from the server. For instance, we want to delete a student entry. Much of the functionality of a web application can be represented under the acronym CRUD, okay, which comes from create, read, update, and delete. Okay, create new resources, read information about existing ones, update resources, and delete them. And there are 4 HTTP methods that correspond to these actions. Okay, for the create functionality, we have the post method. For the read functionality, we have the get method. For the update functionality, we have the put method, and for the delete functionality, we have the delete method, okay? Let's see an example. Suppose we have this action called add, okay, that receives a parameter of type string called title. In this action, we are creating a movie based on the title. Uh, we can tell from the name of the action that it creates a new resource, okay? Here, based on the title, we create a new movie. So in this case, a post verb or method should be used. And in the last, in the lower section of this slide, we can see how the action is decorated with the attribute HTTP post, okay? So basically here we are telling the server that we are creating a new resource. Okay. In case we want a particular action to support several HTTP methods, we can use the attribute accept verbs. In this case, we have an add action that and in this action we want to create a movie in case it does not exist in the database, or in case it exists, we want to update information about the movie. So basically we want to treat two scenarios. One that creates a new resource, and one that updates information about an existing resource. In order to specify to the server that we want to handle these two cases, we can use the attribute accept verbs with two parameters, post and put respectively. Of course, in practice, it's recommended to have two separate actions. One for the create scenario, okay, one that uses the method post, and a second action, one used for updating information about an existing resource, about an existing movie. Now, let's see the difference between the methods post and put. They are very similar because they both send data to the server, data that the server stores. Okay. But on one hand, the method put is idempotent. It means that if the same put request is made two times with the same parameters, the second request will have no effect. Okay, so let's suppose we send a request for updating information about the movie two times with the same information. The first time, the information about the movie will get updated into the database, but the second time, the request will have no effect, okay? For this reason, the method put is generally used for the update scenario. And then we have the method post, which is not idempotent. It means that making the same post request two times with the same parameters will cause two different resources to be created, okay? So if we send two HTTP requests with the same data about the movie, actually it will be created two instances of the movie, two different instances, but of course with the same data. For this reason, the method post is generally used for the create scenario. Now, let's take an overview on dependency injection and inversion of control, two design patterns built in ASP.NET Core. Dependency injection is a design pattern where an object receives the other object. They are called dependencies that it needs from an external source rather than creating them itself. So basically, when we use dependency injection, an object does not create by itself the objects that it uses, but it gets those objects from an external source, okay? And we'll see immediately an example how it gets them. Instead of a class directly instantiating its dependencies, those dependencies are created or injected from dependency injection naming into it. And typically these objects are created using the constructor, the most common way, using properties, or using methods. The advantages of using dependency injection is that The classes do not depend on concrete implementations, as we get the instances from an external source. The dependencies can be replaced with mocks. So basically the app is easier to be tested. And the implementations can change without modifying the dependent class. Basically, the application is easier to maintain. What is a dependency? Okay, so basically it's quite simple. Suppose we have class A that uses the methods of class B. Class B is a dependency of class A. Inversion of control. It's a design principle where the control of the program flow or the object creation is transferred from the application code to a framework or external container. Okay, so basically we have, like we said before, an external source that creates the objects that we use. Instead of the code deciding when and how the dependencies are created and executed, an external system, for instance a framework, container, or runtime, manages that control and calls the code when needed. Okay, and again the advantages are that the components are loosely coupled. We get better modularity and extensibility and a simple configuration for our application. Here we have an example. So normally how do we do it? We write service equals new payment service service.process. So basically we create in the code a new instance of an object using the keyword new. Okay, so here we create an object of type payment service and then we execute the method process. When we use inversion of control, a framework or container creates the payment service object for us and then calls the process method automatically at the runtime. Okay, so basically we are not the ones who create the instance of the object and call the method process. We have a framework that does this for us. What's the relationship between dependency injection and inversion of control? Dependency injection is a way to implement inversion of control. Inversion of control is the broader principle and dependency injection is a specific technique used to achieve it. ASP.NET Core is designed to support by default dependency injection pattern. The platform contains a built-in inversion of control container. And the classes or types managed by the container are called services. The platform can inject means create services, okay, of a dependent class object through constructor or through method parameters using the inversion of control container, and we'll see immediately how it does this. The container provided by ASP.NET Core is represented by the interface iService provider, which supports by default the injection through the constructor. There are two types of services in ASP.NET Core. On one hand, we have framework services. These are the services that are part of ASP.NET Core platform, such as iApplication Builder, iHosting Environment, iLogger Factory, and other ones. These are services that are provided to us and we can use them in our application. And on the other hand, we have application services. These are services, custom types or classes that programmers create for the application. Okay, so these are basically services that we define and we use them in our application. So in order to use services, first we have to register them with the inversion of control container so that it can create them automatically. Can anyone say a service that we have registered last time and we used it in our application? When we talk about database, what class did we create and it was a service? The context class that it's used to interact with the database, it's basically a service. We registered it in the program class. Now let's see an example of a service. Okay, it's a simple service used for logging messages. In order to define a service, first we have to create an interface. In this case, it's the interface iLog. In C# to define an interface, we have to use the keyword interface, and usually, as a naming convention, the name of the interface should start with I. What's an interface? It's actually a contract, that specifies the methods that the dependent classes need to implement. In this case, the iLog interface provides the method info. This method receives a parameter of type string that stores the text that we want to log. Below we have the implementation of the interface in the form of the class console logger. The method info receives the parameter, the string, and then displays it into the console. Okay, so if we go now to the application, we have a services folder. Inside this folder, we have another one called interfaces. And inside it, we have the iLog interface, exactly as on the slide. And below, we have the class console logger with the implementation of the interface. We said that the services of the application should be registered in order to use them using the built-in inversion of control container in the program class. The services are registered using the web application builder instance. Okay, and if we go to the program class, here on line 8, we have this call, yeah? Here we register a service. We register the service that we have seen earlier, yeah? In order to register a service, we have to call the method add, provide a parameter of type service descriptor that allows us to define to register the service, and this one receives two parameters on constructor. First is the interface, okay, and then is the instance of the interface, in this case console logger. So add method of the iService collection instance is used to register a service with the inversion of control container. The class service descriptor, it's used to specify a type of service and its instance. In the example, we have seen that iLog is a type of service and console logger is its instance. Now, important, when an iLog object is included as a parameter to a constructor or method within the application, the inversion of control container will create a singleton object of the type console logger. Singleton is a life cycle. And now let's see what are the life cycles supported by the services. The built-in inversion of control container manages the life cycles of the registered services. It will automatically destroy a service according to the specified life cycle. And the built-in inversion of control container supports three types of life cycles. Okay, we have singleton. Here the container will create and share one instance for the entire application lifetime. We have transient. The container will create an instance every time the service is requested. And scoped, the container will create an instance per scope. In general, one instance for each HTTP request. Going back, here, when we create, okay, when actually no, when an object of type console logger is created, its life cycle is singleton. Okay, so basically it's an instance that will be reused, okay, for the entire application lifetime. ASP.NET Core provides extension methods for each type of life cycle. We have add singleton, add transient, and add scoped for each type of life cycle. But you can use the method that we have seen earlier, add that registers services with the singleton lifecycle for your projects. Now let's see how to do it in practice. Once the service is registered, the inversion of control container will automatically inject it through the constructor if it is specified as a parameter. And here on the right we have an example. We have the home controller, and if we check the constructor, notice it receives a parameter of type ilog. Okay, that's our service. The inversion of control container will inject or create an instance of that service. In this case, it will automatically send an instance of type console logger that we can use in this controller. Okay, and if we go back to the application in home controller, let's put a breakpoint on the constructor and run the application. So if we check this instance, we can see that basically using dependency injection, the inversion of control container has created an instance of type console logger. Okay, so notice we don't do anything. Okay, the inversion of control container takes care of us and creates the instance. Then we can save that instance in a field and we can use it later in an action, for instance in index, to log a message to the console. Okay. Another way to inject services is using actions. Okay, maybe we need a service only in one action. We don't need it in more actions. In this case, we can inject that service only on the action that we need it. How can we do that? Okay, so now I'll just remove this from the constructor. I'll comment these lines of code. Okay, and I want to inject that service on the index action. How can I do that? First, I have to use this attribute from services, and then specify the service. Okay, and now the inversion of control container will automatically inject here an instance of that service, and we can use it in this action. Okay. So here it was instantiated an object of type console logger. Okay. So you have to do something similar for your assignment. You have to define services and inject them either on the constructor, either on the actions that you need them. Here you have a practice task to implement a simple service for data processing. So first you have to define an interface, like calculator service, with methods like add, subtract, multiply, and divide. Then you have to implement the interface in a class called calculator service and register it as a service in the program class. Next, inject the service into a controller. So basically you have to create a calculator controller and create actions that call the service methods. And in the end, to test the service, generate random test numbers inside the controller actions, call the service methods, and display the return results in a view using viewBack object.